So let somebody read this question for us, please.
Find out how long it takes a investment to double if it is invested at 9% compounded round to the nearest tenth of a year. Use the formula A equals P. 1 plus R over N.
Okay. So this is a formula we have. So let's see what we know here. The sound was a little bit low here. I hope everybody could hear this, but we all can read this again. Let's find out what is the values. Can somebody tell me what is A according to this problem? The information is given to us in this problem. What is A? What's the amount here? Do you think it is? Anyone?
A would be 2,900.
Okay, Sebastian type 2,900 times 2. Yeah, that's it. 2,900 is the principal, the P, how much we're investing. So 2,900 would be how much money we're putting down. Does that make sense so far? Right? So amount would be, we want to double that, right? So what would be the amount then? Amount would be 2 times, like we have somebody posted here for us, would be double that. We want to double that amount, right? So what is that? 5,800, right? So we want to double our money. So amount that we want to have finally would be 5,800. Does that make sense so far? Okay. So what's the rate? What is R? It's given to us, right? What is R?
9%.
9%. So which is 0.09, right? Let's put it in the terms of the decimal. What is N? What's N? It's compounded semi-annually. So what is N? If it's compounding semi-annually, how many times they're going to revisit this interest per year?
Semi-annually twice, right?
Twice, 2 times, yeah. So it would be 2, because semi-annually would be 2. So N would be equal to 2. So the only thing is we don't know is T. That's the time that we're looking for. So this is how we solve this. Can somebody tell me what would be a first step here? To isolate T, what would be a first step? That should be easy. What's the first thing we do to solve this for T? We should eliminate 2,900. How do you eliminate the 2,900? Anybody with the mic?
Divide both sides.
Yeah, divide both sides by 2,900. Okay, so what do we get in the left-hand side of the equation then?
2.
We just get 2, very good. So we get 2. So I'm going to carry on here. So we get 2 is equal to 1 plus 0.09 over 2 to the power of 2t. So let's figure out what this is. What is 0.09 divided by 2? They give me 0.045, right? 0.045 plus 1. Okay, so it looks like a 2 is equal to 1.045 to the power of 2t. Okay, now what would be the next step? How do you solve for t here? Anybody? Any idea, anyone?
Square root?
Not square root, because the variables is that in the exponents now. When the variable turns out to be in the exponents, Can somebody tell me what would be the step? Anyone? Okay. This is where you take a log or natural log of both sides of the equation. So I'm going to take a natural log ln, and I'll show you why. We have a little property that help us to do this. So if I take a natural log here, we have one property here. Let me write it down here with different color. So if I have a natural log of x to the power of n, I can move this n and write it right front of natural log. Okay, so this n here, okay, go back and review some of those sessions I had on a property of logarithm and talk about this. It goes right here. I can move it right there. That's what you can do. You can do the same thing with the log. Okay, so I can write here use different color for the log. If I have log of x to the power of n, I can move the n right front of that. So that's how you can move that variable the exponents right here, this t, just 2 right front of it in this case, can move right front of this. Okay, so this would be 2t times natural log of 1.045 is equal to natural log of 2. So we know how to solve for t now. If I divide both sides by the coefficient of t, which is natural log of 1.045, natural log of 1.045, we also have to eliminate that 2 then, right? So I can multiply both sides by also 1/2. So here we have it. So t, we isolate the t finally. So t would be equal to natural log of 2 over natural log of 1.045, and then we have 2 here also. To solve for t, we just have to grab our calculator and enter these numbers there. That's all you have to do, is just enter the 2. A natural log of 2 would be 0.69 if you use your calculator. 0.69. And if you go ahead and evaluate a natural log of 1.045, you give you 0.044, 0.044, and also you have this 2 here. Just use your calculator. And those of you with the calculator, just can go ahead and try this and see what you get. You should get 1/2 times 15.747, 15.47, 15.747, 1/2 times 15.7.7, and finally you would get something called 7.87 years. 7.87, 7.87, 7.8, almost 7.9. So 7.9 years. So that's why the answer would be D. So from here on, you have to use your calculator once you get that. But let's review this quickly that everybody understand the steps. So once you plug the number in, you get to this point here, you eliminate all the numbers here to isolate T. So this, from here on, probably was something that was new to most of you, because the variable you're solving for happen to be the exponents here. You need to take a natural log of both sides because of these properties here that I put out here. This property here, these two properties. So in here, you would take a natural log of 2, and then you can move this 2t right in front of this, and then isolate t. And the rest is just cranking this number in your calculator to get the right number.